Let me show you how the Gweike G2 Pro 30-watt fiber laser will take your projects to the next level. This powerful fiber laser can perform deep engraving in a variety of metals such as brass and aluminum. And it can engrave different colors in stainless steel. And it can even engrave certain colors of 3D printed PLA. Hi, I'm Ken of Rist Innovations, and I have organized the video into chapters listed in the description that will allow you to skip around the video depending on what is important to you. I would like to thank Gweike Cloud for sending me the G2 Pro 30-watt fiber laser engraver for my evaluation. Okay, let's get started. First, let's cover the features. The G2 Pro is a 30-watt fiber laser engraver using a 1064 nanometer wavelength IR laser. This engraver is great for almost all metals including stainless steel, brass, gold, silver, titanium, aluminum, pewter, and steel, as well as stone and dark plastics such as acrylic and even 3D printed PLA. It doesn't work with glass, clear plastics, or wood. The G2 Pro has two main pieces, the laser source and the laser head, connected by a fiber optic cable. There are galvo mirrors in the laser head that direct the laser through the lens down to the workpiece. The laser can engrave very quickly and has a maximum speed of 15,000 millimeters per second. Since it's a pulsed laser, you can control the amount of power in percent and the frequency of the pulses from 20 kilohertz to 200 kilohertz. There are two versions of the G2 Pro. Option 1 has a manual Z adjustment and the maximum work area is 110 millimeters by 110 millimeters. Option 2 has a motorized Z adjustment and the maximum work area is 150 millimeters by 150 millimeters. There are three ways to focus the laser to your workpiece. Number 1 is the pointer. You can measure the thickness of your workpiece and move the Z-axis using the pointer as your guide. The laser focal length is 261 millimeters. The second option is converging red dots. By moving the Z-axis up or down, you can see two red dots that move either closer together or farther apart. So when they converge into one dot on your workpiece, the laser should be focused and you're ready to go. The third way to focus the laser is to place the included ruler on top of your workpiece and measure 261 millimeters to the bottom of the laser head housing. If you need a special part made and you don't have the capability in-house, I have the answer for you. This brings me to the sponsor of today's video, PCBWay. PCBWay is a great resource for PCBs, CNC machining, sheet metal fabrication, injection molding, and various 3D printing, including metal printing. I have personally used their services to 3D print a stainless steel insert for a high wear application. I went on their website, uploaded my design, selected stainless steel and quantity, and I received an instant quote. Then, after their engineering team reviewed and approved the quote, and they received my payment, they manufactured the parts and shipped them right to my door. Their customer service and quality of parts are excellent. Give them a try by using my affiliate link below. Now, back to the show. The G2 Pro includes brackets and screws to locate your workpiece, especially for engraving multiple parts. Also, if your workpiece is too large, you can remove the bottom of your base plate and engrave on your workpiece directly. The G2 Pro also has a tilt feature that allows you to rotate the laser head at an angle. And there are these little detents to lock it in place at various angles. It's also very portable, weighing only 6.5 kilograms, so you can remove the laser head from the Z-axis and use the shield for more portable work. The G2 Pro comes with a small exhaust fan. However, the fan is not very powerful, and I don't really see the value to exhaust the fumes into the room. So I made this adapter to connect my large exhaust system that vents all fumes to the outside. Now let's talk eye protection. Even with the optional safety enclosure, the basic unit is an open design, which means you can be exposed to the laser, which can damage your eyes. So it's critical that you wear laser-approved goggles. Gweike includes a basic pair of laser glasses, so I use this pair of laser goggles that fully protect my eyes. They're comfortable and they are certified for this laser's 1064 nanometer wavelength. A link is in the description below. So I view the safety enclosure as a secondary protection, so you should always wear your laser goggles, even if you are using the enclosure. Once you've assembled the laser, which I'll cover in the next section, to turn on the laser, just turn the key to the right, which acts as the power switch. Then push the laser button to enable the laser. The G2 Pro comes with its own application software. However, it's also compatible with Lightburn software, which is my preferred laser software. A link for Lightburn is in the description below. The G2 Pro also has two optional rotary accessories, which allow you to engrave cylindrical workpieces such as tumblers and rings. They have a new 4-in-1 rotary attachment that they will be launching soon. So I will have a follow-up video on that once I receive it. So let's talk pricing. At the making of this video, May of 2025, the current pricing of the G2 Pro with the manual Z-axis and the 110mm square work area is on sale for $1,799, normally $3,499. And the G2 Pro with the motorized Z-axis and the 150mm square work area is on sale at $2,099, normally $3,899. I have some good news. Gweike has given me an additional $200 off coupon code for the G2 Pro to pass along to you. So if you click on my affiliate link in the description below and type in RIST, you'll receive an additional $200 discount. Now, let's cover the unboxing and setup. The G2 Pro arrived well protected in its packaging. It's pre-assembled right out of the box, and it only takes a few minutes to attach the Z-axis to the base and the laser head to the Z-axis. The box includes the base plate, safety glasses, cables, hardware, the Z-axis, a ruler, laser head bracket, laser supply, and the laser head. To assemble, first attach the Z-axis to the base plate with 4 screws. Next, attach the laser head bracket to the Z-axis, followed by attaching the laser head to the laser head bracket. Then attach the focus pointer using the double-sided tape supplied. Next, remove the lens cover and attach the optional laser shield. Connect all the cables and you're ready to turn on the laser. Now, let's look at the impressive capabilities of the G2 Pro by engraving some parts. The G2 Pro excels especially in engraving a variety of metals. Let's look at anodized aluminum first. The G2 Pro does an amazing job in engraving anodized aluminum in any color, extremely fast and of an excellent quality. It can even cut these thin 0.19mm thick anodized aluminum business cards very quickly. The engraving settings were a speed of 2500 millimeters per second, power at 55%, frequency at 30 kilohertz on one pass. And cutting the aluminum business cards, the speed was 100 millimeters per second at 80% power, 30 kilohertz, and 6 passes. The G2 Pro also does a great job in engraving raw aluminum. Here's an example of 4 totally different looks in engraving, depending on the speed, power, frequency, and number of passes. In this example, the speed range was 100 to 1000 millimeters per second, the power range was 35% to 100%, the frequency was 25 kilohertz to 80 kilohertz, and the number of passes was 1 to 3. The G2 Pro also handles brass with ease. Just as with the raw aluminum, this brass engraving sample shows a variety of looks using different settings. In this example, the speed range was anywhere from 200 to 1500 millimeters per second. The power range was 75% to 100%. The frequency was 45 kilohertz to 50 kilohertz, and the number of passes was 1 to 5. The G2 Pro and other similar fiber laser engravers also do a magnificent job in deep engraving in certain metals such as brass. The G2 Pro can engrave up to 3 millimeters deep in metals. Deep engraving of brass coins is very popular, so the first thing I did is I went on to the 3D Grayscale website and purchased a couple of deep engraving files. Next, I imported files into Lightburn software. Next, I tried a variety of settings with mixed results, but then I found a YouTube video from Gweike and I had my best results using their settings as follows. The engraving settings were, for the deep engraving, a speed of 2000 millimeters per second, a power at 85%, frequency at 20 kilohertz, and the number of passes 255. Setting it up in a bidirectional engraving pattern with a line interval of 0.0127 millimeters and the image format as 3D sliced and a scan angle of 0. Then I included a cleanup pass with the following settings. Speed 1000 millimeters per second, power at 30%, frequency at 50 kilohertz, and 1 pass, and everything else was the same. This deep engraving of the brass coin turned out beautifully, and it took about 2 hours to engrave. And you can adjust that based on the number of passes that you want to set up. Next, I engraved this pewter using the following settings. A speed of 330 millimeters per second, a power of 15%, a frequency of 25 kilohertz for 1 pass. Now, it's time to show you some really cool things you can do with engraving stainless steel. The first application is basic engraving of my name on one of my wrenches. To get this very nice dark engraving, I use the following settings. Speed of 1050 millimeters per second, a power at 40%, frequency at 35 kilohertz, and 3 passes. Now, to get wild and crazy, let's find out the best settings to engrave a variety of colors on stainless steel. I made these 2 material tests using the following parameters. A power range of 20% to 70%, frequency at 20 kilohertz to 70 kilohertz, and a speed constant at 1000 millimeters per second with an interval of 0.001 millimeters and 1 pass. I created a second test with the same parameters, but I made 2 passes on the second test. I was blown away at these beautiful colors ranging from light blues to yellows, greens, pinks, and dark blues. So let's engrave this bug on a piece of stainless steel. This thing turned out beautiful. Now, let's move on from metals for a minute and talk about engraving stone, specifically slate. Look at how great engraving on slate turned out. Here's an example of 4 totally different looks in engraving depending on the speed, power, frequency, and number of passes. In this example, the speed range was 70 millimeters per second to 1200 millimeters per second. The power range 35% to 100%. And the frequency was 25 kilohertz to 65 kilohertz, and the number of passes was 1 to 5. I did do some limited engraving on black acrylic. The best setting I found so far was the following. A speed of 1050 millimeters per second, 40% power, 35 kilohertz, and 3 passes. I need to spend some more time on optimizing the best settings for this material. The last test I performed was to try to engrave on 3D printed PLA, which is polylactic acid, which is the most common plastic used in 3D printing. I made this material test using the following parameters. A power range of 5% to 65%, a frequency of 5 kilohertz to 50 kilohertz, and a speed of 2000 millimeters per second, 1 pass. First, I tried engraving the black PLA. The results are intriguing to me. So for instance, the lightest, most easily noticed engraving setting was at a 15% power, and it looked the same at the full range of frequencies. But it wasn't even lighter at a 5% power. In fact, the engraving was darker at 5%. I tried other colors of PLA, including blue, orange, and white, and the laser had no effect on any of these parts. So it's clear that the color of the PLA really makes a difference on whether or not it can be engraved or not. And this is true also for acrylics. In my opinion, the Gweike G2 Pro is an excellent fiber laser engraver. I was blown away at the speed and precision of the engraving in a variety of metals as well as slate. The fact that it can also engrave black acrylic and 3D printed PLA is a big plus. The G2 Pro is very lightweight and portable, and another major benefit is that it's compatible with Lightburn software. The only common complaint that I have seen on YouTube is that the cord to the exhaust fan is quite short, and since it has to plug into the main unit instead of the laser head, it has a limited range. In my opinion, the exhaust fan is too small to be really effective, and I don't want to be blowing contamination into my shop anyway. I found the solution was by making an exhaust adapter to my shop exhaust, which exhausts everything outside. I think this is a very valuable tool that most people could benefit from having it in their workshop or small business. Thanks for watching. Bye!